Moving into the second decade of the 21st century, we face growing challenges which require us to respond with innovative and unique solutions. Our energy needs continue to grow. At the same time, we must reduce our emissions. We must reduce the environmental and economic costs of providing and maintaining landfill sites. One company has addressed all of these issues with a stunningly efficient and effective solution. The company is Premier Green Energy. The solution is the Prima 3000. The Prima 3000 takes various waste fuel source feeds and, using a process called pyrolysis, produces a number of useful byproducts, including a large volume of high calorific syngas, ideal for powering a gas engine for the clean and efficient generation of electricity. The Prima 3000 can operate efficiently on a highly diverse range of fuels, including refuse-derived fuel, also known as municipal solid waste, wood chip, biofuels and rejected crops, sewage sludge and industrial waste, shredded tires. The chosen fuel source is loaded into a hopper. Each load is weighed individually before entering the hopper, allowing for accurate recording of the amount of fuel used. A conveyor system takes the fuel up to the compactor hopper. Here the fuel is compressed into pellets by hydraulic rams to exclude air containing oxygen. The fuel pellets then enter the in-feed hopper, from where they are fed via a scroll into the main retort. In the main retort, in the absence of oxygen, pyrolysis of the fuel takes place at 600 degrees centigrade. Heat and fuel in the presence of oxygen will burn. Heat and fuel without oxygen produce pyrolysis. The exclusion of oxygen means that no harmful dioxins can be produced. The syngas produced in the Prima 3000 by the pyrolysis of the fuel is taken from the retort and is quenched. This is the first step in conditioning the gas to produce a clean product with a high calorific value. The gas is then put through a wash tower, where it is washed in a medium pressure gas wash system. The gas now passes through a dual tower gas absorption system for further cleaning. In the case of this demonstration unit, the clean, high calorific gas is burned off in a flare mechanism. From biomass fuel, the Prima 3000 produces gas with a typical calorific value of between 16 and 20 megajoules per meter cubed. From refuse-derived fuel, the Prima 3000 produces gas with a typical calorific value of between 20 and 24 megajoules per meter cubed. The second product of the Prima 3000's pyrolysis process is char. Char is a combination of carbon and ash. The char exits the retort and travels along a char cooling scroll to a char storage tank, from where it is fed via two scrolls to fans which deliver the char to the thermal oxidizer unit. The two scrolls before the fans control the volume of char being sent to feed the thermal oxidizer unit. Inside the thermal oxidizer, forced draft fans generate temperatures of 1250 degrees centigrade. The hot flue gases generated from the combustion of the char are circulated through the outside skin of the retort, where the heat radiates through the walls and into the fuel, which causes pyrolysis to happen, producing syngas and char. The Prima 3000 utilizes a very efficient process and has a low parasitic load. The hot gases from the thermal oxidizer, which has heated the retort, are passed on to a heat recovery system, which can generate hot water or steam, depending on what is required. This system can supply hot water to local houses and businesses. On this particular Prima 3000 demonstration system, the heat is dissipated through a fin cooling system. The remaining gas is then passed through a ceramic dust collection system before exiting via chimney. The chimney is independently monitored and certified to ensure that the system performs to optimum levels. The final byproduct of the Prima 3000's pyrolysis process is an inert slag, produced when the char is sent to the thermal oxidizer. It is a fusion of ash and any inert materials, and it can be used in building materials and in road building. The control room for the Prima 3000 is a fully automated SCADA-based control system. All temperatures and pressures are constantly monitored and adjusted to ensure that the Prima 3000 runs at maximum efficiency. The Premier Green Energy Prima 3000 is capable of converting 3 tons of fuel per hour into cheap, clean electricity. It has a small carbon footprint for a system that will have such a big effect on the future of waste usage and power generation. The Premier Green Energy Prima 3000. The clean, green, waste-to-energy machine.